Hi, I'm Chin. I'm Camille's explainer buddy. Today, we will talk about psychology of language, recognizing visual words.
Have you ever wondered how your brain instantly recognizes words on a page?
Without you even realizing it? Today, we're diving into the fascinating science of recognizing visual words, a key piece of the psychology of language.
Word recognition refers to the process of identifying written words and accessing their meaning.
Recognizing a word on a page isn't just about seeing letters. It's about your brain instantly matching those shapes to sounds and meanings. This process is automatic, fast, and surprisingly complex.
According to Harley 2014, it's one of the most studied areas in psycholinguistics because it gives insight into how language is stored and processed in the brain.
But how do scientists study something as invisible as word recognition? Harley outlines several experimental methods. Participants are shown letter strings and asked, "Is this a real word?" If the word is common, like house, response times are very quick. This tells us about word frequency and recognition speed. But for rare words or non-words like flirp, responses are slower. Participants are asked to read words aloud as fast as possible. Timing these responses reveals differences between easy and difficult words. When people read, their eyes move in small jumps called saccades. This reveals which words require more processing time. Tools like fMRI and EEG show which brain areas are active during reading. For example, the left occipitotemporal region lights up when people read. Findings from these methods converge. Recognition is rapid, but shaped by frequency, familiarity, and context. Harley 2014 identifies several key factors that influence recognition. Frequency. Common words like book or house are recognized more quickly than rare ones. Word length. Short words tend to be processed faster, although high-frequency long words can still be recognized rapidly. Neighborhood density. Words with many similar neighbors, like cat, can be recognized more quickly, but sometimes neighbors compete and cause confusion. Repetition. Words encountered more than once are processed faster later on, a finding called the repetition priming effect. Orthographic regularity. Regularly spelled words like mint are recognized more easily than irregular ones like pint. Together, these findings show that recognition is shaped by both experience and word structure.
Attentional processes in word recognition. So, attention plays a crucial role. Harley points out that when we read, our eyes don't glide smoothly. Instead, they make rapid jumps or called saccades between fixations. During each fixation, only a small part of the text is processed in detail. So some words are skipped entirely if they're short, frequent, or predictable. In contrast, rare or unexpected words cause longer fixations. This shows that attention is selective, guiding recognition and making reading efficient. So, is there a dedicated visual word recognition system? Brain imaging research shows that word recognition isn't just general visual processing. According to Harley 2014, the visual word form area, or VWFA, in the left occipitotemporal cortex is activated specifically when we read words. This suggests that reading uses a specialized neural system. Interestingly, Harley notes that writing is only a few thousand years old, too recent for evolution to create a brand new brain area. So instead, reading likely co-opted existing brain regions for object and pattern recognition, adapting them for written language. Meaning speeds recognition. Harley describes this through semantic priming. Words are recognized faster if they are preceded by related words. For example, doctor primes nurse, making it easier to recognize.
Processing morphologically complex words. Understanding morphological processing. Recognition of words often involves morphology, the analysis of word parts, aiding comprehension. Complex words may be identified directly or decomposed into morphemes like prefixes, roots, and suffixes by the brain. Example, unhappiness breakdown. Prefix. Happy, root. Ness, suffix.
Context also plays a role.
Meaning state of
in
being
sentence
unhappy.
like she spread the butter on her,
Morphological
the
meaning
brain
biology.
anticipates the word
Knowing
toast,
morphemes like
so
bio,
recognition
life,
is
and local
nearly
study helps
instantaneous.
infer meanings of
This
new words
shows
such as
that
biology.
word recognition is interactive.
Morphological
Bottom-up
decomposition
input
is
from
crucial
letters
for learning new
combines
vocabulary
with
and
top-down
understanding unfamiliar
predictions
words.
from meaning and context.
Enhance your reading by exploring the power of word parts.
Forster's model suggests the mind organizes words in frequency-ordered bins, like a filing system. Common words are stored at the top of the filing system for quick and easy access. Less frequent words are stored deeper within the filing system, requiring more search time. During reading, the brain searches these frequency-ordered bins until a match is found. The frequency-ordered structure optimizes word retrieval efficiency during language processing. Morton's logogen model proposes that each word has a corresponding logogen or counter. Each time related clues are encountered, the corresponding logogen counter accumulates. Once a logogen reaches a specific threshold, the word becomes activated. Logogen activation leads to instant word recognition. The interactive activation and competition IAC model explains word recognition as a network of interconnected letters, sounds, and words. Perceiving a letter activates related words within the network. Activated words send feedback signals to their constituent letters, reinforcing connections. This interactive process strengthens correct connections and weakens unrelated ones. Through competitive activation, the brain identifies the correct word.
Many words are ambiguous. They have multiple meanings. Harley explains that when we encounter such words, our brains briefly activate all possible meanings. For example, bank activates both the financial institution and the riverbank. For example, bank activates both the financial institution and the riverbank. Context quickly resolves the ambiguity. In "she cashed her check at the bank," the financial meaning is selected. In "he sat by the bank of the river," the other meaning is chosen. This shows that recognition is flexible. Instead of waiting to commit, the brain activates several options in parallel, then uses context to select the right one.
So, to summarize Harley's 2014 insights, we have visual word recognition allows us to connect written symbols with stored knowledge in mental lexicon. Researchers study it through tasks like lexical decision, naming, eye tracking, and brain imaging. Next is recognition is influenced by frequency, length, repetition, neighborhood effects, and orthographic regularity. Attention directs which words we process most carefully. The visual word form area shows that the brain has a specialized system for reading. Context and meaning facilitate recognition through priming. Morphological decomposition helps us understand complex and new words. Models like the logogen and interactive activation models explain recognition through each is incomplete. Finally, ambiguity is resolved by activating multiple meanings and using context to choose the right one. As Harley reminds us, word recognition is a window into how the brain organizes and processes language. By studying it, we learn not just how we read, but how the mind turns symbols into understanding. That's all for now. Thank you for watching.